Hi everyone and welcome. In this video we will cover that how to integrate REYAX RYLR998 LoRa transceiver module with Node-RED. Okay, so here on the camera you can see I have this two transceiver LoRa modules from REYAX. Okay, now we want to integrate this two module with the Node-RED. So if you are using any Linux single board computer, okay, and if you want to transfer the data between two Linux single board computer using LoRa, then you can use this two module with the Node-RED to transfer the data. Okay, because these modules are compatible with the Node-RED. You can transfer your industrial data over the LoRa module as well. Okay, you can transfer some sensor data or you can transfer OPC data as well. Okay, everything you can transfer over the LoRa using these two REYAX LoRa modules. So in this video we are going to integrate these two modules with the Node-RED. So how you can integrate it? Okay, so for that I have already created the Node-RED flow. So this flow is for the first module and this flow is for the second module. Okay, so here on the camera you can see I have this two module which is connected with the USB to TTL converter. So here I have CP2102 USB to TTL converter, and here I have RYLS135. Now this I got it from the REYAX. Okay, so here you can read the details. Okay, REYAX RYLS135. So this is also USB to TTL converter but with the more functionality, and this is our normal CP2102 modules. Okay, you can install the driver for this module in your system. You can search on the Google to download the driver and you can install it. Okay, and now I have connected these two LoRa modules with this two USB to TTL converter, and the connection diagram you can see here, okay, on our GitHub repository. So I have provided 3.3 volt, okay, and RX is connected on the TX pin and TX is connected on the RX pin of RYLR998, and here is the ground pin. Okay, so on the same format I have connected these two modules with this two USB to TTL converter. Now once you plug this with your system you will get one COM port, and once you plug this into your system you will get second COM port. So we are going to use the COM port, okay, to send the AT commands to this module, and based on this AT command this two module will talk to each other. I hope you got my idea. Okay, now let me plug the first module. Okay, so I have plugged the first module with my system, and let's open the computer manager, this PC, manage, device manager, and in the ports you can see we have Silicon Labs CP2102 USB to UART bridge connected on the COM4. So this LoRa transceiver module is connected on the COM4. Now we'll connect the another one. Okay, and we'll again open the device manager, and here you can see the second module, okay, which is connected on the COM8. Now we know that which module is connected on which COM port. Now we can use our Node-RED flow. So yeah, here what you have to first do is you have to double click on this response from first module. Okay, and here you can see I have created two serial port connection. The one is for the first module, okay, and the second one is for the second module. Now we will click on the first one and we'll click on the pencil icon, and here you can see I have attached the serial COM port 4, okay, because our first module is connected on the COM4 and our second module is connected on COM8. Now in the COM4 you have to select baud rate 115200, okay, data bits 8, parity none, stop bit 1, DTR auto, RTS auto, CTS auto, and DSR auto, and this should be blank. And here you have to select split output on the character /n, And I mean, all those things are as it is. Okay, you just have to change only two things. Once you add this node, you just have to add COM port, and you just have to select the baud rate. Okay, after that you can cancel this one. And here also we have the serial out. Okay, so double click on the serial out, and here you have to select the same module which you have configured for this one. Okay, so now the question is, from where you will get this serial in and serial out. So if you double click here you can see this is the serial in node, and if you double click here, then here you will see the serial out node. So from where you will get this serial in and serial out node, so you can go to the manage palette. Okay, and here you can search for serial. Here you can see node rate serial port. You can expand this, and here you can see serial out, serial in. Okay, so you have to use this node, okay, or you have to install this node in your system to get serial in node and serial out node. Okay, so I hope this thing is clear. Now this serial in node will read the data provided by any LoRa transceiver modules. Okay, so it will provide the data to your system with the serial connection. Okay, so we are using this serial in node to catch the data, and we are using this serial out node to provide the AT commands to our LoRa modules. Okay, I hope this is also clear. Okay, now whenever we receive any response from the LoRa modules, we are going to use this debug node to print that response in the debug window. Okay, and on the second flow we have configured everything for our second LoRa transceiver modules. Okay, so if you double click here, if you click on this pencil, then here you can see we have configured COM8 port because our second LoRa module is connected on the COM8 port. Okay, then after we have selected baud rate 115200, and rest of the thing is similar to the first one. Or if you add this node here, then you don't have to change anything because you will get everything as it is. Okay, so this is what you have to do first of all. Then after I have added few nodes here, okay, few inject nodes to get the data of our LoRa module and to set the data to our LoRa module. So I'm going to the first flow. Now, yeah, give me a moment. Okay, now here you can see I'm going to deploy my flow first. Okay, here you can see it is connected, and it is connected on the COM4, and for the second you can see it is connected on the COM8. Okay, so both COM port are in use. Now we will first check the LoRa module status. Okay, so you can inject this, and here you can see we have received the output. Okay, so our first LoRa module is okay. Now we will check the address of this LoRa module. So I'm going to inject the second node, and here you can see address is 2. Okay, that is also fine. Then after we will check the network ID. So I'm going to inject this one, and here you can see network ID we have received is the 5. Then after we will check the LoRa band, and here you can see LoRa band is 915 megahertz. Okay, and here you can inject this node, and you can check the last payload we have sent. So we haven't sent anything, so that's why you can see 00. Okay, so this is what the status of our first LoRa module, which is connected on the COM4. Now we will check the status of our second LoRa module, which is connected on the COM8. Now I'm going to delete everything. Now we will check our second module. So you can see we have received the response okay. Then after we will check the address. So the address is 1. Okay, then after we'll check the network ID. So network ID is 5. Okay, previously also the network ID was 5. Here also the network ID is 5. So to communicate these two LoRa modules, okay, network ID should be same and the bandwidth should be same. So we have checked the network ID for both. So network ID is same. So let me check for the first one. So here also you can see network ID is 5, and here the address is 2. Okay, for this one the address is 2, and for this one the address is 1. I'm going to change it later on. Okay, now for the second module, okay, we'll check the band. So band is 915 megahertz. For the first module also we have the same band. Okay, and for the second module we'll check the last payload. So we haven't sent any payload from this module, so that's why we will see 00. Okay, so this is how you can check the details of your LoRa modules, okay, using the Node-RED. Now you can use Node-RED to interchange the data between these two modules. Suppose you have the scenario where this module is connected to some other single board computer or other computer, and this module is connected on the other computer. And if you want to transfer the data, if you want to send and receive the data between that two computer without any Wi-Fi, without Bluetooth, without GSM or any other mobile network, then you can use this LoRa to transfer the data. Okay, so that's why we are going to use the LoRa. You can also control some equipments using LoRa. Okay, so everything is possible with the LoRa. Now for the first LoRa module, we will set the band. Okay, we will set this band. I know which is already set, but again we are going to set it. So I'm going to set the band. We have received the response. Okay, then after, for this module we are going to set the address to 1. So here you can see 80 plus address is equal to 1. So we are going to set the address for this module to 1. Okay, we have received the response. Okay, then after we are going to set the network ID 5, okay, for this module, and here you can see we have received the response. Okay, now we will check the band first. Okay, so band is already set. Now we will check the address. Address should be 1, and then after we will check the network ID. It should be 5. Okay, so everything is set up for this module. Now we have to set up everything for this module, which is our second module. Okay, for the second module we will set the band 915 megahertz. Okay, so let me inject. We have received the OK response, so band is set. Then after we will set the address for this module is 2, because this is our second module. Okay, so I am going to inject this payload. Okay, output is okay, and I'm going to set the network ID to 5. Okay, and all are okay. Now we will first check the band 915 megahertz. That's fine. We'll check the address. Address should be 2, and we'll check the network ID. It should be 5. Okay, so both of the LoRa transceiver modules is having network ID of 5, and the bandwidth is 915 megahertz. This module is having address of 1. This module is having address of 2. Okay, we are going to use the address to send and receive the data. So that's why we have to set the address. If you set both address same, okay, this module is having address of 1, this module is having address of 1, then you can't interchange the data. So both of the module should have different address. Okay, network should be same for both of the modules, so they can be in the single network, and bandwidth also should be same. Okay, so you have to take care of those things. Now here I have created one inject node to send payload from first module to the second module. Okay, so here you can see 80 plus send, okay, is equal to, we want to send the data to the second module, so that's why 2 is there. Okay, so we are going to send data from first module to the second module, so that's why I have kept 2 here. Now 6 is the byte number, or you can say the count of character. Okay, so here you can see 1 2 3 4 5 6. Okay, so Fusion has 6 character, so that's why you have to add 6 here, or you have to provide 6 here. Okay, and once you inject it, here you can see this is the output from this node. Okay, and here you can see this is the output from this node. Okay, so we have sent data from our first module to the second module, and here you can see second module has received the data. Receive, okay, from first 6 character, and the character is Fusion. I am not sure about the terminology of -3 and 11, but I am very sure about this first 3 terminology, that we have received the data from first module. The character length is 6, and here is the character, okay, which we have sent from the first module. So this is how this is going to be work. Now what we will do is we will send the data from second to 1. Okay, so here is our second flow. So here you can see send payload from second to 1. Okay, send payload to 1 from 2. Okay, sorry, my mistake. Send payload to 2 from 1. Sorry, really sorry about it. So here we have sent data from first module to the second module, okay, in the first flow. And in the second flow, we are going to send data to the first module from the second module. So what I can do is I can check the data. So we are going to send the automate, okay. So this is what the data we are going to send. So what I will do is I will press inject here. And here you can see this OK output is from this debug node, and this receive output is from this debug node, because our first module has received the data. And here you can see what it has received. So receive from second node, okay, or second device, total 8 character received, and here is the character, okay, which it has received. So it's totally wireless communication, okay. You can place this 2 LoRa transceiver module anywhere in the open area, and you can transfer the data. So if you have 2 single board computer, okay, suppose if you have Luckfox Pico Mini B, Luckfox Pico Pro Max, Raspberry Pi, Banana Pi, Orange Pi, or anything, or if you have some industrial PC, then also you can use these 2 things to send the data, or you can say to interchange the data. So if you have solar field, okay, and you have this 1 LoRa transceiver module, and you have some 10 to 20 LoRa transceiver module, then you can broadcast your data from 1 to another 20 LoRa transceiver module to set your panel angles. Okay, so that is possible. So in the case of setting up the solar panel angle, you can use one sender and multiple receivers. Okay, so when your multiple LoRa receiver will receive the data from one sender, they will extract the data from this kind of output, and then after they will set their angles. Okay, you can also integrate these 2 modules with the Arduino ESP32, Raspberry Pi Pico, or any other single board computer. We are going to cover that how you can integrate this LoRa transceiver module with a single board computer using Python. Okay, so instead of Node-RED, you can also send and receive the data using Python. So if you have any sensor data which you are reading from the Python, and then after you want to broadcast that sensor data to different LoRa node, and from the LoRa you want to set some motor angle, set some output, then also you can do that. Okay, so all those things we are going to cover in the future videos. I was very curious about this integration, Node-RED and LoRa module integration, so that's why I have created this video, and we are successful. We can integrate LoRa modules with the Node-RED. So all you have to do is you just have to grab the CP2102 USB to TTL converter or UART converter. You have to attach your LoRa transceiver module with this. Okay, you can buy 2 CP2102 modules, and you can buy 2 LoRa transceiver modules to exchange the data. Okay, now this 2 Node-RED flow can be run in different system. Okay, so you can run this first flow in the first system, you can run second flow in the second system, you can copy this entire flow, and you can also run the same flow in the third system. Okay, so you can run the Node-RED flow in the multiple number of system integrating multiple LoRa modules. So that is also possible. Okay, I have kept this Node-RED flow on the GitHub repository. Okay, so you can go to the Node-RED folder, and here you can get the Node-RED flow. This is for the first device, this is for the second device. Okay, so this is the first, this is the second. Okay, and if you have multiple, then also you can use the same flow. Okay, you just modify few things like address and payload. So if you have third device, okay, or if you have third LoRa transceiver modules, then instead of one here, you can type 3 to send the data to that third LoRa transceiver modules. Okay, so that is so simple with the Node-RED. And we'll also cover entire thing in the Python as well, that how you can integrate this two LoRa transceiver modules with the Python, because Python is one of the easiest solution along with the Node-RED. Okay, so either you can run Python to read the data from industry, or either you can use Node-RED to read the data from industry, and then after you can use LoRa to wirelessly transfer your data over large distance. Okay, so I hope everything is clear, and if you still have any questions or any doubt, then you can always ping me on Telegram, Instagram, WhatsApp, anywhere. You can also comment on this video. Also, you can send me a mail. Also, you can chat with me on LinkedIn. Now we will meet you in the future videos, and in the future videos we are going to see that how you can integrate this RYLR998 LoRa transceiver modules with the Python, JavaScript and LuckFox boards. Okay, and I have also uploaded the Node-RED flows on this blog. Okay, so you can open this blog and you can have the Node-RED flow. Okay, so this is the first flow for your first LoRa transceiver module, and here you have the second flow for your second LoRa transceiver modules. Okay, so let's meet in the future videos. Till then, take care, goodbye, and thank you.